Okay, now we are going to discuss Unit 2 revision class. Okay, these all are the basics. Okay, you can go through it, you can understand easily. These are the basics. I will discuss only hybrid pi model, how we are going to hybrid pi model, how we are going to okay hybrid pi model, how we are going to draw, I will tell. Okay, we know that this is a transistor. Transistor have three terminals: emitter, base, collector. We know that transistor. Okay, transfer to design transfer. One of the condition is okay. Area of the collector region is greater than area of the emitter is greater than area of the base. Okay, here each area or each material. Okay, for example, this is a collector region. P type of material. It is made by NPN transfer. N. This is emitter also N, and base is P. Means okay, collector also one of the material, emitter also one of the material, base also one of the material. Now we know that resistance of the each material is R is equal to rho L by A. Resistance and area both are inversely proportional. Both are inversely proportional. So here area of the collector is greater than area of the emitter is greater than area of the base. Okay, then it is in the reciprocal. Then resistance at the collector region is less than resistance at emitter region less than resistance at the base. Now, to represent the resistance here, now I am going to keep one virtual base terminal B dash. I am going to keep it here. Therefore, okay, in the base region, in between B and B dash, one resistance is there. That resistance we can call it as a RB dash. RB dash. This resistance name is RB dash. In between collector region and the virtual base, RC dash. In between virtual base to emitter, one resistor will be there, RB dash. RB dash in the base region, RC dash in between, okay, collector region and the base. Okay, it is in between base and okay, emitter. Base in the sense virtual base. Virtual base. Okay, there are three resistance we are having, and there are two capacitance we are having in between collector and B dash virtual base. That capacitance name is CB dash and CB dash. Okay, this is the okay. These are the internal capacitance and internal resistance of the BJT. Now, to draw hybrid pi model, see here, to draw the hybrid pi model of BJT at high frequencies. See, hybrid pi model we are going to use for high frequencies. Hybrid model or H parameter model used for the low frequencies. Hybrid pi model. Now see here. Okay, here B is there, B dash is there, here C is there. And we know that common is emitter terminal. Here emitter terminal, here emitter terminal. In between B and B dash, one resistance is RB dash. In between B dash and C, okay, here it is C. Here it is a C. This total thing is C. Okay, RC dash or RB dash C, whatever it may be. Okay, next one more resistor is in between B dash and emitter. This is entirely emitter. Okay, RB dash E, RB dash E. Voltage of across here it is VB dash, VB dash across this resistor. And there are two capacitance, that is CB dash in between virtual base and the emitter, and in between collector and here CB dash. Okay, and these all are the these are the internal parameters, and we know that okay, if you consider okay, transistor is a BJT is a current control device. That's why VB dash into GM. It is nothing but current. VB dash into GM. GM is nothing but 1 by R. Then we are having one okay, dependent current source. After that output resistance RCE. This is RCE, or I can take it as a DCE. If you take reciprocal, it will be DCE. And in between collector and emitter, okay, we have the output voltage is VCE. Output voltage is VCE. This total setup we can call it as a hybrid pi model of BJT at a high frequency. This is important for 2 marks. This is important for 2 marks question. Next one. Okay, here they are going to ask very frequently. They are going to ask. Okay, repeatedly they are going to ask a few questions. That is hybrid capacitance. Okay, hybrid pi capacitance and hybrid pi conductance. Now, in this one, in this model, I am going to take it as a CB dash E. Okay, and C C B dash E. Two capacitors are there. C B dash E also called as a C phi. Please keep in mind C phi. C C B dash I can also call it as a C mu. Why it is called as a pi model? If you observe here, this okay, if you observe the hybrid pi model, this is look like a pi. This setup is look like a pi. Why this setup one I am concentrating? Because this is a feedback. Feedback is nothing but a output is connected to the input. Output is connected to the input. Output is connected to the input. Okay. Here output and input. Okay, there is a connection. Please keep in mind there is a connection. If you take hybrid model, there is no connection between input and output. Input side and output side. Or input node and output node, there is no connection. Now, C dash is is between virtual base and emitter. Okay, generally base and emitter is connected in forward bias. So C dash is called as diffusion capacitance. Please keep in mind. This is called as a C dash is called as a diffusion capacitance. And C dash is connected in between virtual base and collector. Generally, collector and base junction is connected in reverse bias in active mode. So C dash is also called a transition capacitance. Transition capacitance. Please keep in mind. Now they asked, one time, okay, they asked in the question, okay, in JNTUA exam, transition capacitance CB dash, okay, and the diffusion capacitance is CB dash. Okay, these two we need to derive. Okay, first I am going to derive transition capacitance CB dash, okay, or this is also considered as C mu. Okay, just now I said that the collector and virtual base junction is connected reverse bias, so the depletion region width will increases. Reverse bias. This is I take it as a this is okay base. This is collector region. Okay, base and collector region. Okay, this junction is JC junction. This junction is JC junction. It is in reverse bias. It is in reverse bias. When it is in reverse bias, what going to be happening? Depletion region width is going to be increased. This depletion region act as a capacitor. That's why C is equal to epsilon A by D. This is a general formula. Okay, general capacitance formula. Okay, what is meant by if you convert this is general capacitance formula. This one you can convert into the collector base junction. In collector base, in the sense this is the B dash. This is which one? B dash. B dash is nothing but which one? Virtual base. In between, okay, collector and virtual base. Okay, it is connected reverse bias. Then I can write as a the capacitance exists in between B dash. Okay, and C is CB dash is equal to epsilon A by epsilon by width of the depletion region at JC. At JC means collector junction. Okay, now we know that the depletion region width at the reverse bias is depletion region width at the reverse bias. W is equal to root of 2 epsilon by cube into 1 by NE plus 1 by ND into V0 plus VR. V0 plus VR. For CB junction, this one I can write as a W. Okay, this is generally depletion region width. This one convert into the for CB junction. W, okay, width of the depletion region at the junction, collector junction is equal to epsilon by Q into 1 by NE means base is P type plus 1 by ND. ND is nothing but collector is N type plus V0 plus VCE. VR is reverse bias voltage. Here, what we are going to apply this voltage name is VCE. This reverse bias voltage name is VCE. VCE. Okay, now we can substitute this value in that equation 1. This is equation 2, equation 1. If you substitute this one, CB dash is equal to epsilon A by root of 2 epsilon by Q into this value we are going to get. This is about the transition capacitance or CB dash or C mu. They can ask any type in the exam point of view. Next, diffusion capacitance. Diffusion capacitance CB dash E or C pi. This capacitance is exist when emitter base junction is in forward bias. Okay, generally the equation of diffusion capacitance is C is equal to dQ by dV. Now we need to find out Q. Okay, to find out Q, what we have to do is listen carefully. For transistor, at high frequency, in between in between virtual base and emitter is CB dash E or C pi is equal to dQ by dVB dash E. V means which one? Okay, applied voltage. Here, input junction side is VB dash E will be there. Input junction side is VB dash E is there. Okay, this is a VB dash E. This is in between. This is the emitter region and the base. Okay, we are going to apply. Emitter is N type. This is the P type. Okay, now it is negative terminal and this is a positive terminal. Then this one here is we have the junction. This is JE. JE is in forward bias. Then here in between this one, I can write VBE in small letters. Sorry, VB dash E. Okay, VB dash E. VB dash E. Now, when it is in forward bias, we know that, okay, here Q I need to find out, Q I need to find out. To find out the Q, okay, generally, if you observe, how I am going to find out? See, after when this junction is in forward bias, this junction is in forward bias, we know that the depletion region will be disappear. After that, the injection of the charge carriers occur. Emitter, it can emit the electrons. Okay, it can emit the electrons into base. Okay, after that, the diffusion process is going to be occur. Here emitter is N-type. Then the diffusion of the, okay, the diffusion of the electrons I can write as a diffusion of the electron. This is the diffusion current density. Diffusion current density. Diffusion current density. Okay, Jn is a Q into Dn into Dn by dx. Okay, Dn by dx. Now this width is, okay, the width of the depletion region I can take it as a, okay, Wn. W, okay, Wb or W, okay, Wb. You can take it as a Wb. Wb. Okay, capital B, WB. From where it can start now, from the junction here, it is 0. Then I can denominator, I can write 0 minus WB, where these diffusion charge carriers, okay, diffusion charge carrier center, their electron concentration is n, and at the end of the, okay, at the end of the junction, the concentration will be 0. That's why n minus 0, n minus 0. Then I can get as a, okay, 0 is a, n minus 0 is n, 0 minus WB is a minus W, minus n by WB. Okay, substitute, this is equation 3 I written, this is equation 2. In place of dn by dx, you can write it as a, okay, minus n by WB. From this, minus q into dn into n by WB. Now, what is meant by Jn? What is meant by Jn? Jn is nothing but current density. Current density is nothing but, okay, current per area. Okay, here which current will be there? Emitter current. I by A is equal to minus q into dn into n by WB. From this, okay, IE is equal to, here I can write IE is equal to, okay, IE is equal to minus Q into A into N by WB into area. Now N is equal to, this is IE is equal, not J, IE, N is equal to, from this, okay, IE minus IE, okay, except N, this is the N, right? This N you can keep left to side and you can send to the remaining parameter right side, minus IE into, okay, WB, width of the depletion region, divided by Q into this is dn, sorry, here it is dn, sorry, this is dn, okay, dn into A, this is equation 4. Okay, next, okay, generally we know that Q is equal to, means charge at junction, Q is equal to charge at base, sorry, charge at base, okay, minus Q into, okay, N into W B dash into A. What is that one? Okay, here electrons are diffused, here charge at base, okay, electrons are diffused in the base. Electrons are diffused in the base. When electrons are diffused in the base, okay, Q is equal to minus for electrons, minus Q into, okay, N. Q means electrons have negative charge, N number of electrons. Where it is diffused in, it diffused in the, okay, width of the depletion region, sorry, width of the base region along with A, okay. This is about charge at the base. Now we need to substitute, this is equation 5, This is equation 5. This equation 5, okay, sorry. In this equation 5, 4 we need to substitute. Where in place of n? In place of it, if you substitute, this is minus q into minus IE into WB by QB into DN into A. Okay, here A will get cancelled. Next one is Q will get cancelled. Then I will get plus minus into minus plus IE into WB square. This is WB square. Width of the depletion region, sorry, base width. WB is nothing but WB square by DN. This is the Q value. Now we know, okay, C pi CB dash is equal to, now we know that C pi or CB dash is equal to C pi or CB dash is equal to D by D VB dash E into Q. Differentiate this Q, okay, differentiate this Q with respect to VB dash E. VB dash E. When you differentiate this one, okay, I will get WB square by DN is a constant. DIE by dVB dash E. DIE by dVB dash is nothing but GM. GM is a transconductance. Transconductance. This is about the C pi or CB dash E. Please keep in mind. Okay. Here we got C pi or CB dash E is equal to CB dash is equal to WB square by DN into GM. Where GM is, we know. This is the important question. Now, basics of RE model, and R pi model. Okay, here RE, R pi, R naught we don't want. Okay, and GM dash using, okay, calculation of RE, R pi. Okay, calculation of RE and R pi GM using hybrid pi model. Okay, here, if you observe here, first I am going to write RE. This is RE. Okay, this is available. This is available. Okay, in CB configuration. At input junction. At input junction. Now, okay, RE is equal to, okay, resistance is equal to voltage by current. Input voltage is, what is this one now? Input voltage is VBE or VEB. Okay, and input current is IV. Therefore, rate of change of VBE by D. Okay, rate of change of VE. We know that. Okay, emitter base junction is in forward bias. Therefore, IE is equal to I naught into, okay, E power. This is E power VB by eta VT minus 1, and eta is equal to 1 for silicon, and here I naught is very small, that's why minus 1 will neglect. Then IE is equal to I naught into VB by beta. Differentiate above equation with respect to IE we are having with respect to VBE. Okay, with respect to VBE, you can get, okay, I naught is constant. Okay, then E power VBE by VT into 1 by VT. Okay, E power X is E power X. Again, X is differentiation of X, 1 by VT. Okay, then I'm going to get here, okay, from this I naught into E power VBE by VT whole divided by V. Okay, VT. I naught into E power VB by, okay, VBE by V suffix T. Okay, VT. In place of this, I can write IE. Okay, because from here, from this equation, I can substitute here. If I substitute in this way, okay, I can substitute here. Okay, where I'm going to substitute? Here I'm going to substitute that IE by VT. Therefore, RE is equal to dVB by dIE is equal to, okay, VT. VT is a thermal voltage. Please keep in mind by IE. Thermal voltage by, okay, VT is thermal voltage by input current, that is input or emitter current, that is equal to what we can get from RE. Okay, we derive RE. Next R pi. R pi is, okay, it is available or occur in CE configuration. CE configuration. This occurs CE configuration. Now check it CE configuration. Okay, R pi is equal to, okay, R pi is equal to input voltage by, okay, output, sorry, input current. Means R pi is the, okay, input resistance per, okay, input junction. We know that. Okay, IB is equal to here DVBE. This is DVBE by DIB. IB is nothing but direct current equation. IB is equal to I naught into e power V by Vt minus 1. Here also eta is equal to 1 and I naught is small. Okay, neglect it means which one, this I naught I cannot neglect. I naught into this one minus I naught will get. That minus I naught we need to neglect. Same, we need to get VBE by IB. Then differentiate this IB value with respect to VBE. Okay, same way I can get here. Okay, instead of this value, I can write as a IB by beta. Then R pi is equal to, it is a reciprocal. DIB by DVB we find out. DVB by DIB is equal to VT by IB. If you observe here, R pi and R, okay, R pi and RE. If you observe here, both are same only. But this is occur in CB configuration RE. That's why we are getting VT by IE. R pi we are getting in the CE configuration. That's why we are going to get, okay, VT by IB. This is important. Next we are moving to the GM. GM is equal to 1 by R. 1 by R is nothing but, okay, 1 by R is nothing but it is a transconductance. Actually, transconductance. Then GM is equal to output current by input voltage. Then IC is equal to I naught into e power. This is a e power VBE by VT. Okay, here I am going to get DIC by DVB is equal to okay, differentiation with respect to, okay, this one. Wait a second. The dV by dVB is equal to I naught into this value. We need to differentiate. To differentiate that, to differentiate if you differentiate that, what will get one? Same way, I naught into e power x, okay, dB by beta into 1 by beta. DIC by dVB is equal to IC by VT. This is looking like a GM is nothing but current by, okay, see here, current by voltage. Okay, please keep in mind. Now this is about the GM, okay, R pi, R mu. Relationship between RE, R pi and GM. First, relationship between RE and GM. RE is equal to, just now we said VT by IE. Okay, this one I can write as a VT by, okay, here this is IE, okay, or else multiply divide with IC will get cancelled, I will get VT by IE only. Okay, now VT by IC is nothing but 1 by GM. IC by IB is nothing but current gain, output current by, okay, input current for CB configuration. Then I can write as a alpha. From alpha, this 1 by GM you could send this side, alpha is equal to RE into GM. Please keep in mind. Now relationship between R pi and GM. Okay, R pi is equal to, we know that. Okay, R pi is, what is R pi now? R pi is equal to Vt by Ib. R pi is equal to Vt by, okay, Vt by Ib. I already said R pi is occurring at C configuration, input junction. Okay, Vt by Ib. Okay, from R pi, okay, you can multiply and divide with the IC. Then Vt by IC is nothing but 1 by Gm into beta. Beta is equal to R pi into Gm. That's it. See here, alpha is equal to Re into Gm. Beta is equal to R pi into Gm. Okay, relationship between Rp and Re, R pi and Re. Re is equal to Vt by Ie. Okay, in place of Ie, we know that in place of Ie, emitter current, I can write Ib plus IC. Ib plus IC. IE is equal to IB plus IC. Okay, from this, okay, IE plus you can write. Okay, when you take IB is common, 1 plus IC by IB will get. Okay, from this, VT by IB and 1 divided by this term, I can write separately. Okay, IC by IB is nothing but 1 by beta. Sorry, IC by IB is beta, 1 divided by 1 plus beta it will become. Then R pi is equal to 1 by, sorry, R pi by 1 plus beta. This is R pi value. Okay, this is the relation formula from Re. What is that one? Re is nothing but, okay, Vt by Ia. Okay, R pi is nothing but Vt by Ib. Re other name is, what is Re other name? Okay, Re other name is R B dash A. Check it. Okay, there it is. Okay, Re other name in CV configuration R B dash A. Okay, this is our relations.